Okay. All right. Can we see number 2? That's number 1, power rule.
Oh, it just gets to that point. Okay.
Wait, I can't see number 2. All right, let's see. Okay, so you're integrating it based off the graph here, okay? Between 1, A is between 1 and 3, but the graph start at 0, ends at 3.
Wait, no. Where does it say between 1 and 3?
The integration, right here, at the integration.
Oh,
Problem, okay.
that's like an option. Oh, never mind.
I think that's the actual attempt
Yeah,
that
yeah,
you're
yeah.
supposed to do, right? So if you do it between 1 and 3, here, I can sketch it quickly here, something like this. But it stops there and it's got to linger there. I think that's at 3. Yeah, it looks like at 3. 1. But what is it? At the least, which of the following has the least value? Well, let me see. If I sketch it like this, do you see what I'm doing? It looks like I'm doing the right side because it's touching the right triangle. So this is the least. So it has to be the right hand. Do you see it? Well, it doesn't matter between 0 and 3 or 1 and 3. It's still going to be underneath. Oh, okay, I'll make it exact. It looks like this. Here, 1 and 3. You can have multiple rectangles in there, but I just use 2 to show you why it's least, because you have gaps in there. You see it? You have gaps right there. So it should be the right hand. So it should be C. If you look at it carefully, do you see the picture?
With 4 sub-arrow equal.
Yeah, I just did 2, but I can make a 4 if you want. But it looks like there's a gap. Even if I did 4 rectangles, it doesn't matter. It's going to be least.
Okay.
Do you want me to do a 4? I can do a 4 if you want. Well, where does it say 4? Oh yeah, it says right there for all of them. But if you want to see 4, I can do it. But it looks like this: 4 rectangles underneath, but there's a gap like right here, like the space there. That's why it's the least. If you do the right hand,
If
it'll
it was
be
on the other side, it would be over it and more.
over it. Yes, and if you do the mid, it's most accurate. But but it's still not. Yeah.
Okay.
You can imagine it. Yeah.
I'm gonna write a note.
Oh yeah. Yeah, this one they want the least value. Yeah.
Okay.
All right.
Number 3.
Okay. All right. They gave you a bunch of givens. Looks like from 0 to 5, and then 3 to 5, and then 0 to 3. Okay. The F and G. Okay. So you want to attempt to integrate that and see what happens here. So let me see. Let me write the problem here from 3 to 0. I don't like the parenthesis. I'll bracket that. G, 3G of x dx. Okay. Let's say symbolically, I think this is where you like don't like it too much. Symbolically, let me think. Where is the? They want you to the breaking. They're breaking everything up here. 1 second. Okay. All right. So you can't really integrate because there's no symbol like the other ones that has like the G prime and all that. You remember? There's none of that. This is actually just all F and G. There is no. So So you have to break it up like generically. Have a look. So I'm gonna do something like this. I think you be fine if I break up the F part. It will look like this. Integration of 0 to 3 f of x dx minus 3. Let me see. You okay with this? So this is generically broken up in, it's the property of the sum and difference.
That makes
So
sense.
g of x dx. And then you use what they gave you. So I think they gave you extraneous stuff. So
Yeah.
yeah. So
You
let's
just
see.
plug it in. So like
Yeah,
of
just
9 and then of 5.
yes. However, one of them looks like you have to flip flop it. You see the last one, this one here, you have to flip flop it. So if I were to flip flop it to match what they gave you, it'll be a positive 7 over here. But if it, anyway, watch. I'll flip.
Wait, but what about from the F's? What do you do about that? How do you find what it is? Because one's from 0 to 6 and one's from 3 to 6.
Oh wait, so you're saying the it's not 5. I can't see. Could you zoom in a little bit? Like
So
the
it's, I
integration
don't
of
have
f
the whole thing, but it's
is
3
it
to 0. But when the F's, it's 0 to 6 and 3 to 6.
3 to 6, 0 to 6, 3 to 6. Okay, that means you have to do it. Yeah, there's a cut here. What property can you use here? 3, 3 to 6, so in between 3 to 6. So 0 to 3. Oh, I see. Yeah, here. So if you do it between 0 and 3 instead of 0 to 6, 6, it's in between. The whole thing. Okay, so we're gonna try this here in a second. If you do from 0 to 6 is 9, but from 3 to 6 is 5. Therefore, the difference is going to be 4 from 0 to 3.
Oh, you
You,
subtract.
you, you get that?
Yeah.
But I should be able to write the property for that. But let's go with that because it's easier. So like this, 1/2 times 4 minus, but this part right here, we remember we're gonna flip flop this, so we're gonna flip flop and make it a positive here, 3. I mean, you can overlook the coefficient if you want, and then do a 3 and 0 and then 3 instead, g of x. And the other way around, 0 here and then 3 here, g of x. You okay? If you look at
Yeah.
it, but then it become a plus -7. Is that what it was? Yeah. So what is that? So is this the answer being what? 19. So this is going to be -21, and this is going to be 2. So yeah, that's the answer, -19. You get that?
1/2. Yeah.
Times. Yeah. Are you okay with the subtraction part? Yeah, I think you. Yeah,
Wait,
yeah.
and it became. I understand the subtraction when you separate it, but how come? Wait,
Okay. So
where did the -4 go?
not
Wait,
-4, +4, right? Because you're going from 0 to 6, but in between
no,
the three.
I get the 1/2 times 4, but then what happened on your other side?
Okay,
Plus,
it become a plus because I you remember when you flip flip that upper and low limit, you flip around upper
yeah.
and low limit, the coefficient will be negative. The front of the integral will be negative. Remember that property? I'll write it if you want. So it's something like this: b a f of x dx. If you switch them like b a now and then b, you get a negative out of it. So this is like the property that you've seen before, equals.
Yeah.
So I did that. I flipped it.
So it
If you
becomes
notice,
+3.
it plus because well, it can't originally negative. So I just flip flop.
Yeah, so it becomes +3 times, or yeah,
Yeah, it's a negative and a
-3.
negative. So I flip
But
it.
then the g of x, shouldn't that be -7?
Yeah, right here times 3. But I
I'm
put 3
sure.
times.
Oh, that's a 7. Okay,
Yeah,
-7.
I put -7 first, but it's a negative. It's a positive
So it's
3 times
2
-7. Yeah, it's a
20.
positive 3 times -7.
Okay, I understand. Okay,
Okay.
4.
All right, 4. Okay, so yeah, this is based off U substitution. So we're gonna do that again. like you done before. But the thing is that it's in F notation. Okay, yeah, okay, that's interesting. All right, here. So take a look. But 1 second here. Okay. So watch. I think you're pretty good with this. I know that there's an F in there, but I know you're actually, when you actually do the problem without the F notation or the U notation, you're good. So if I were to do this, let's see, you're going to be okay. I'm going to rearrange the x to the d next to the dx, and it will make sense. So it's supposed to be taught this way, by the way. Now, okay, I'll still put the upper limit here. Now I'm going to let u equals to the x minus 3, like that. Is that okay? And then I'm going to take the derivative of du. Let me see what notation they use. Yeah, they use du. Du, I'll do it like this. Dx equals 2x. But oh, yeah, you already know it ahead. I think you do it faster. It's like this: 2x dx. Okay? You agree?
Yeah.
And then solve for this right here. So I'm going to solve for x dx. So it'll be 1/2 du equals x dx. So if I do that, it will look like this. Have a look.
Wouldn't it be negative? Oh, wait, oh, no, never mind.
Okay. So if I do that, it will look like this. But once you actually use U notation, your upper limit will no longer be 5 and 2. So I'll leave it blank for now. It'll be f of U 1/2 d for now. 1/2. I'll make direct substitution du. Do you see that so far? Okay, then it looks like they only give that. Okay, no big. I'll put this in the front, and then now I'm about to solve for the new upper or low limit. So
Wait, but our
okay, I'll make it this clean right here. So step by step, so far,
oh yeah.
so far. You okay with the coefficient
Yeah.
being pulled out? Next thing, I'm gonna do u the u when it's 22 here. I guess I don't know. You want to notate that it'll be x22. Wait, I'll do u2. I'm gonna do u2 here. And u1, u2, okay, never mind. You understand. So u1, I'm going to go ahead and plug in with the 22 squared. Wait, no, I'm sorry, 5 squared minus 3, which is going to be 22. So that's going to be the first u, the second u, 2 squared minus 3, be 1. You agree? So it'll be 22 here and 1 here. So now everything's in terms of u.
But don't we already have that because we had 22 to 1?
Well, you didn't know that. You're not supposed to know that. They gave you, yeah, you do it so that it appears to be 22 over 1. You didn't know that. You didn't know that ahead of time. So now you do. Now that it makes sense that you can use the 5. You get it? Like when you do it, and then all of a sudden it turns 22, one of them, and the other one's 1. And then it matches what
If it
they
doesn't
gave.
work, then do you not use the 5?
Oh, you have to use the 5 if and only if you got the U correct, the 2 U's. So
Oh, okay. Never
it
mind.
does work. Therefore, you have a 1/2 times 5 in the end. Let me double check. Yeah. So in the end, it's 1/2 times 5. So it's 5/2. There you go. I hope you're okay with that. Yeah. Once again, you're trying to write everything in terms of U, and hopefully you match the 22 and 1, and it does. If you didn't, that you made a mistake. So they made this problem to work itself out with that given, you know, the integral of 22 over 22 and 1. Hope you okay?
Yeah, that makes sense.
All right, good.
Okay.
All right, next one.
Do I need the formula for this one that I'm supposed to have?
Yes, you do, but you have to do more than that to get it. But okay, so how would you know, right? It looks, you have to kind of, this is based off experience. You know, I don't agree that you're supposed to know all of it. To me, it looks something like this. Have a look. Based on what I see, like the original problem, let me show you what I mean. You have to have some kind of experience knowing what type of integral that you're allowed to, or you're supposed to know. Like here, x squared something here, x squared something right there. Automatically to me, it's either one of those like, hey, a constant like a 1, a number like an a minus or plus an x squared in the denominator of the integration, something like this. This is my a, okay, like a constant. So that means you have to look it up. That means you're supposed to know that it's
I have like a
it's a
formula
trig.
sheet.
Yeah, it's a trig. It's a trig integration. But let me look at it here. But have a look. See, like it's one of these here. It could be a root, but it's not a root. But you see, it's like it looks like this one, like the tan inverse and the cotangent. You see that? Like one of them. That means you have to actually complete the square to get the answer. That's how I see it. But this is not the A version, so I have to look for the constant version. This is like just 1. Sorry, but where's the 1 version? This is the one right here. But no root. Okay, here. Oh, and it's the same. I know you have it. I know you have it in front of you, but I don't have it memorized. So let me look at it carefully. This one. Oh no, it's the A version. What is happening? What's wrong with?
Oh wait, which one of these would that be?
Let me see. I'll show it to you right now if I can find it. Come on, image. All right. With the A being part of it, not just 1, but the 1 is. If not, I can work with it. But so you have to look for the A. Here it is. There we go. Oh, but they give you the log stuff. Let me look carefully. Okay, it's the third one. You see that? It is the third one. Um, I'll screen capture that and I'll bring it in. Now, do you have something similar to that for you to look at?
I have these like a picture of just like the board.
Okay, but that means you have to have one of them that looks like it here.
Yeah, I'm looking through them right now.
So it's the arc10, but it's also the 10 to the negative 1. Is that okay? It's the same thing. Let me highlight it here, right here. It could be it's of course you can see the arc 10 instead.
Oh yeah, we did this today. This is recent. Okay, I was looking at the wrong ones. I have it right here.
Okay, so here we go.
Du over a squared plus u squared. Yeah. Okay.
Yes. So what you have to do is you have to complete the square in the denominator. Have a look. And I'm glad they give you the 1 being the coefficient of x squared. So take 8. You're doing BC technically here. I don't know you realize it, but
That's so dumb.
yeah, 4 squared, 16. So have a look at what's going to happen here. You remember completing the square? So here. You add 16. Now this is actually side to side. We're not doing algebra 2 method that you bring over the other side of the equation. None of that now. This is like pre-cal and beyond. Now it's calculus. Minus 16 or plus 17 first. It doesn't matter. So, but you need the plus 16 for the trinomial. You don't do a minus, you do a plus 1. So here it is. So if I continue, then it would be this plus 4 squared for the trinomial plus 1. Oh, nice. It's a 1 so far. That's nice. Then I rewrite to match the form of the integral. Oops. So if I rewrite it, it will look like this. Oh, from the original problem here. So of course I didn't pretend I copied the original, and now the next step looks like this. After you complete the square, it'll look like this. So far, the dx. Is that okay? You see that?
Yeah.
And then you can use the formula directly. It's either arc or the inverse notation. Okay, so here we go. 1 over 1 over 1. They even did the 1. That's interesting. Normally they leave that 1 over 1 out. Okay, and then tan inverse is arc tan. It's okay. And I think you got the rest here. Just like that. See, like the x, this whole thing is the x position right here. You get it? Like the x plus 4, that's your x. That's it. So it's x plus 4
Okay.
over 1. But they emphasize the 1 for you. That's nice. There you go. Done.
Okay, that's not too bad.
It could get bad when your A is something else. Your A is something else. Oh, man. Okay, why am I cannot clear it? Okay, whatever. I'll just open a new one. All right. This one, yeah. Of course, I'm gonna split this into 2. It would be this 2 plus. Well, you don't have to do this, but this is good for you to follow here for sure. I'm sure it's cleaner. I mean, here it is. I split into 2. The first one is gonna be 2x. What's the plus? Yeah, it's a plus. Yeah, plus. This one, I think you know your formula, right? It's going to be, oh, don't forget, sometimes if you split them, you have to actually treat each one, you have to evaluate each one separately like that. Okay, or you can do them together. I think you probably like to do it together, right? I don't know. What do you think? What do you think what I've written so far here? I
And
split
normally I
them?
split them.
Okay, good. I think you should. And then, what is it? It's, what is the formula? Okay, I don't have that down, the exponent.
Let me find it.
I did it with you one time. I don't know you remember it.
For which
ln
one?
for the ln, yeah, for this ln. But here, so here's the formula.
Oh, it's just,
The exponent. Sorry, the exponent.
isn't it A over ln A? Or A something over ln A?
Yes, that's exactly it. This one right here. A.
Yeah, A to the X.
Yes, it's going to be a to the x, a to the x over ln a, a to the x over ln a. So here we go. It's going to be 3 to the x over ln 3, and you evaluate between 2 and 0. You okay? I don't know if
Yeah.
if this is like the notation you teach have taught you. Some teacher will bracket this, parenthesize that, But the clean it is just the bar thing. Sometimes they put it right behind the bar, like this, like 2 and 3, like the bracket. I'm sorry, like 2 and 0, like the last
That's what
bracket.
he does.
Yeah. So this is actually, there's so many variation of it, but it means the same thing.
Okay.
So okay, so this is what your teacher did, like right here, like this, like that. But it's awkward, so I'm gonna leave it like this. This is the cleanest looking one. Right, so let's do it. So it's going to be 2 times 2 minus 0 for the first one, plus 3 to the second power over ln 3 minus 3 to the 0 power over ln 3, and then simplify. So this would be 4 plus 9 over ln 3,
Over ln 3
and then you have common
minus 1.
denominators 1 over ln 3. So that's why it's 8
So 8. 4
ln 3.
plus 8 over ln 3. Oh,
Yeah,
okay.
common denominator. Okay. Okay.
Yeah.
All right. Next one.
7.
Okay. So this one you have to do substitution. You just want. I'll bet you know it really well because
Yeah.
yeah
The use of.
yeah you sub. But if you wanted to do like the cleanest way, you reorganize the x to the third next to the dx. I don't know if you, I don't know if you actually realize that is the arrangement when you do the use substitution. It looks exactly like it. Yeah, the ones that teaches that is the easiest to follow like this. So I reorganize the x next to the dx, and then when you do the u substitution, and it makes sense if you look at it carefully here. X to the fourth du equals, or x here the dx. So and
And then
then
1
1/4, yeah, du
x
extra
cubed.
dx, and then you, if you want to be clean, you can still leave the 1/4 directly below it, like this,
Mm-hmm.
du, and then you can pull it out later. I'll do that just to keep track. Then I pull it out, and oh, good. I'm glad there's no upper or low limit. So
Which
this is
wouldn't it
u, yeah,
become?
u, yeah,
Wouldn't it become
yeah,
1/4 du sine u?
yes,
Or
yes. So far, yes, like this, du. Okay.
yeah.
And then you integrate in terms of u. So integrate this in terms of u. So you integrate sine, it's a negative cosine, but you have a 1/4 there. Might as well put it in the front. Is that okay? To put it in front of the 1/4. So it's cosine of u. Yeah, that's it. But then now I'll write it like this for now. Plus c. But since you don't have an upper or low limit, you can back substitute it in terms of u. Don't forget the original problem is written in terms of x, therefore your answer must be in terms of x. So you cannot leave the u. Think about it, okay? Because you don't have an upper or low limit. So the answer must be in terms of x. So you back substitute this right here, and then you're done.
Okay.
So yeah, if you think about it, it makes sense. Yeah, the problem is in terms of x. The answer must be in terms of x because you don't have an upper or low limit.
Mm-hmm.
Okay. All right. Write the solution to differential equation. Now, you are right. I think you've seen me done like the split before, and it makes the most sense that way. If not, it
Yeah.
will be like very awkward if you do it any other way. So have a look here. So the x term is on this right side. So multiply dx over, what is that, 10? Yeah, dx over, and dy here. And here we go. You integrate this right now, both sides. So I'm gonna put it in between the 10 here. I know I think you understand that. Like you can put it in front of the 10, but I'm gonna have to pull it out anyway in front. So it'll be y here. But now from your derivative, what the derivative of what? It's cosecant squared. Do you remember? Cotangent.
Cotangent.
Yeah, cotangent. Is it negative or positive? But let me go ahead and write that first. Plus c.
D
Why
or
is it
C?
c? Oh, yeah, I'm trying to erase that thing. Okay, if I take the derivative of cotangent right now, it will be a negative. Therefore, you have to counter it with a negative. Do you see it? So I'm putting a negative in right now. Yeah, so if you take the derivative of anything c, you get a negative. That's why you have to counter it to get a positive back. This is positive here. It's positive here. So that's why it's going to be a negative. And is that it? Oh, no,
Yeah.
because
No.
not yet, because you have to
You
solve for
add
c.
the.
Yeah, you have to solve for c. Do you see it? So it says that,
Mhm.
hey, your y will be 4 when remember in algebra, I don't know, you interpret that y of
Plug it
pi
in
fourth.
there.
Yeah, your y is 4 when your
X is
x
power.
is, yeah, your x is pi fourth plus c. So you solve for the c. what is cotangent of? Yeah, what is
It's rho
cotangent?
2/2 times 2. Isn't that just 1?
1. Yeah, so it's going to be a negative 10 times 1 plus c, and that's it. And then you add both sides by 10, and you see is 14, positive 14. So c
Okay.
equals 14. And then you reuse this whole thing with the c being 14. Is that okay? That's it.
Mhm.
And is that it? Yeah. Yeah.
Yeah.
All right. All right.
Number 9.
Okay. So I think you remember this one is more common. So I do know the ln one. You remember it's something like this. Dx. It's supposed to
Yeah,
be
this is just
x plus c. This one is more common, so I do know it. So here it is. But you have to use substitute it to be neat because of the 3x. There's a coefficient, that
so
thing
u
right
is
there.
3x minus 4.
Yeah, but if you do enough, you don't probably even do use substitution because you can see it really, really fast. So, but I'll do it because I think you still have, it's still kind of new to you. That's what I think. So here, it'd be let u equals 3x minus 4, du equals 3 dx. So it's 1/3 du dx. So therefore, u substitution will be 1 over u, well, 1/3 outside here, du. Is that okay? And then integrate that normally. It's just like use this property right here. So it'll be ln of u, but absolute value, plus c, but 1/2 here. Now wait, if you think, hey, what about 1/3 distributed to c? Yes, it's supposed to, but the c absorbed the 1/3. I don't know if you see that. Yeah, because if you integrate it, the 1/3 is supposed to be multiplied to everything that you get out of the integral right behind it, right here, including the c. So this c
Okay.
technically is 1/3 c, but when you absorb it, it becomes another c. It's just another c.
Okay.
That's it. So anyway, it's a ln of a back substitute. Again, it's an x problem. It's in terms of x,
Okay.
and that's done. Okay.
Okay.
Yeah. Okay. Looks good. Yeah. Looks good. Okay.
Average value, that's 1 over b minus a, right?
Yes, yes, that's right. So we're going to do 1 over 0.5 minus 0, but it's going to be 0.5. Is that okay? Integrate 7 and root of 1 x squared here, dx. Okay, so there is a formula for this, but let me prep it first. So it'll be 2 times 7 over, okay, this is going to be 2. And this is going to be, I'll pull out the 7, and then I'll be left with this. I'm just going to clean it up a little bit here before I use it, before I use the formula.
You made it 2 point, or, wait.
2 times 7,
Oh, okay.
right? 1 over 1/2 is 2, but I pull out the 7 outside. So it's 2 times 7 would be 14. So I'm prepping for it right now. Then I'll look up the integration formula for this, unless you know it. So integral,
A 1 over, no, actually I have no idea.
if you're not sure, you just look up integration of a root, but it's going to be reciprocal, but I'll just say root. And here it is, the very first one here. Wait, is it a plus or minus? It's a minus, yeah. It's a sign, arc sign. Do you see that? But let me double check here. Yeah. Hey, why Yeah, you okay so far? Yeah.
Yeah.
So it's an arc sine, the first one. So it's going to be 14 arc sine or sine inverse if you want arc sine. But you do it, oh, forgot to put the upper low limit from the beginning. 0.5, 0, 0.5, 0, 0.5, 0. So we're going to do this between 0.5 and 0. Hope you're okay with that.
Yeah.
Okay. So then you're supposed to do 14 times. I don't like writing arc. I'll write it like this. Minus 0. Okay, then you're supposed to remember. I'll leave the 14 out. What angle in radians will give you a y value 1/2? This is what this is.
What angle in radians will give you a y value 1/2? Pi over 6.
Pi over 6. And then what angle will give you the y value of it being 0? What angle will give you?
Or
I'm sorry.
0.
What? Yeah. What? Yes. Is that right? What angle will give you the y value of 0?
2 pi or 0 or
0.
negative.
0. Right?
Yeah.
Because yeah, it's 0. So the answer should be 14 pi over 6, but reduce that. What is that? 7 pi thirds. But what did they say? Let me see. Let me punch this in. Is that the correct answer? 2.33 something?
Let me put it in the calculator. 14.
Yeah, that's the answer. That is the answer. Because 7/3 is 2.333, but you have pi right at the back there. You see it? So this is the exact answer here. There it is. 7 pi thirds. I hope you're okay with that.
Yeah. Okay.
All right.
Tosh, do you think we can actually end at 5:50? Is that possible?
Yeah. Is that okay?
Yeah.
Yeah.
That'll work out better for me because I have to go after.
Okay.
Okay, 11.
Now, here's the thing. This one is like the easiest if you know your formula.
I just memorized a bunch of them.
Yeah. So let me see what will be the best way. All right. Let me show you. I think you might recognize it. Okay. So, but you have an upper and low limit. So, which is the better version? Here it is. So now this is the easiest if you have this memorized. Why? The easiest, you're not going to get anything beyond this one. The honors one will have like, instead of x, you'll have like x plus 3 or 2x squared or whatever, even more challenging. This one is a plain one, like I don't know, it might not look plain to you. So if you use this formula, this is done. If you look at it, it's going to be done. So the answer, if you look at it carefully, your x will be replaced or will be substituted in the t, and you're done. But you have to remember that
That's the only thing.
That's the only thing.
Okay.
Recommend you just, yeah, you can copy this down. I recommend you copy this down. So that's why, but yeah. Now, that you may ask, what about the E? Okay, let me answer that. The E, the E for number 11, the low limit, the E could be 0, 5, 7, 11, pi. It will still be the same answer. How about that? Is that okay? Because A is just a constant. That's how this works. So they're trying to like confuse you. Well, hey, you got to use the E for the ln. No, it doesn't have to. It could be any number, still the same answer.
Okay.
Wait, is that okay? Yeah.
Yeah, that makes sense.
Okay, good.
A lot of sense.
Yeah.
Okay.
I hope you copied that down. Did you copy that down? Okay.
Yeah, I just put it down. I said replace
All right.
the X or the D with the X.
Yes. Okay. All right. Next one.
Okay. This might be last one.
Okay.
Is that big enough or should I zoom in?
Oh yeah, it needs. Yeah, I need to see it. It's too small. Okay, that's better. Okay, so this is the graph, and it seems like they want you to do a left-hand one. Oh, no, left, right, and trapezoidal sum. Okay, I don't know if you ever seen that. This trapezoidal sum, it's actually the most accurate of the form, like of the
That's the
shapes.
basics, right?
Yeah, it's more accurate than the midpoint. Remember the midpoint? Yeah. So let me see. Of this, you're gonna do for this particular under this particular curve between 0 and 1. It's using the same subinterval. The graph, could you scroll over a little bit?
It
To
just
the
is the
right.
graph you showed.
The graph of the function shown above. Okay, let me see. Good. And which sum gave you the overestimate? Okay. Well, I mean, this I don't know why they make it so wordy. So have a look. So I want to sketch it. I don't think they care for how many intervals here. I'll just do a couple here. So if I do under, it will look like this. Let me see first. Let me try it. Here's the first one. Here's the second one. Here's the third one. If I do under, right, it's a left hand. Could you tell? It's a left hand. If I do under. Now, automatically, it will be the other one. if it says over. Yeah, if it says over, then you have to do the other one. Now, oh yeah, but wait, let me show you the trapezoid. Yeah, what about the trapezoid, right? But wait, let me do the over then. The over will look like this then. It'll be the right hand. Do you see it? The right hand. The right corner of a rectangle here. Here's a right hand. That's the over. Okay?
Yeah.
But then you may ask, what about the trapezoid?
Right.
Yes. So it has to be the other one opposite of the left because it's under. Because just if you attempt to sketch it, you'll get it right away. But now, what about the trapezoid? Now, you may not have seen this, but it looks like this. Now, the trapezoid will look perfect. Watch. I'm going to try it, okay? It will look like this.
Oh, yeah. But it's the same idea.
But it's under. Yeah, it's same idea. It's under. Therefore, it will not work. Get it? But it's the most accurate, though. But it's not what they're asking. Yeah, this is a trapezoid one. If you ever wonder how it's done, it will stretch at. Look at that. It will stretch like pretty like tangential. That's the way they talk to the curve. So, but it's still under. Therefore, you cannot accept that. So that's it. So it should be the right sum, the right hand.
Okay. Then I think we're fine. I only have 4 more, and then I'll just review those on my own.
Okay.
That's not too bad. I usually do it a bunch of times. It's normally what I do just did. Yeah.